So, all right, so this is going to help you in preparation. We're going to review things from all of Unit 1 for clinical calculations. So I have it recording, and for those that are watching the recording, hello. But when I propose a problem to you, just pause the video and try to attempt to complete the question, and then play the video so you can watch it, how we break it down and how we do it. So the first type of question you should be prepared and ready to come across would be just simple conversions. And this is why we asked you to memorize all of the equivalents, because you cannot bring the equivalents with you to your exams. The only thing you can bring is a 25-button calculator and a pencil, and everything else is left at the front of the room. Don't forget your IDs, and they will give you a paper examination. So on the examination, it may say something as simple as this. So if you're watching the recording, just pause the recording. And for everybody else, please solve this equation and then put your answer in the chat if you want to. We're going to do this one together. So JL, definitely check your rounding, and don't forget your unit of measure on the exam. Oh my gosh. All right. I'm so sorry. They're clicking in to get in. Hold on. All right. So the question asks you to convert 2,765 micrograms to milligrams. All right. So I'm going to use the dimensional analysis method because that's what we teach. All right. Paula, check your rounding. Here we go. So I start with my given, and my given is what is given to me. Or in the case when we start doing medications with physician orders, it'll be the physician order. So I'm going to start with 2,765 micrograms. Now I like to put that over 1 because I am making fractions when I solve these problems. So I always remember the top is the numerator, the bottom is the denominator. My wanted is what? Milligrams. So I always put that at the end of my problem. And I put it over 1. That reminds me that I need milligrams to end up in the numerator. So that's important. So while looking at this, I have to think, how do I get micrograms to milligrams? And that's where you go into your memorization toolkit. So you should remember that 1 milligram equals 1,000 micrograms. And that you can use for your problem. But how you set up your problem is just as important as knowing where to start and end. So with terms, when we deal with mathematics, in order to get rid of the micrograms, we have to put the micrograms in the denominator. So this will allow us to cross off like numbers or like lettering in this case. So I will put 1 milligram over 1,000 micrograms. And when I do that, I can cross off micrograms, and that leaves me with only 1 unit of measure, which is milligrams, and it is in the numerator position. So I'm done. Now it's just math. So I will multiply 265 micrograms times 1. And I put that over 1,000 because 1,000 times 1 is 1,000. I do the math, it will give me 2.765. So what is the rules? Numbers between 1 and 10, we round to the 10th space. The 10th space is 1 number to the right of the decimal. So I have to round to this number. So I look to the number immediately to the right. It's 5 and higher. So this number gets rounded up. So my answer, my final answer, will be 2.8 milligrams. And that is all you need on your answer line. Beautiful. All right. Let's do another one. Let's keep it going. Keep the rhythm going. All right. Let's do this problem. So what is my given? 18 ounces. Convert 18 ounces. I put that over 1. And my wanted is cups. Not a problem. Put that over 1. I need cups in my numerator. So how do I get rid of ounces and get to cups? Well, if I can't remember anything about ounces and cups, I mean, the easy way is I can say, what? There are 8 ounces in 1 cup. Okay, I'll use that one. 8 ounces in 1 cup. That will allow me to cross off my ounces. That will leave me with cups. So now it's just math. So 18 times 1 is 18. and 8 times 1 is 8. And when I divide 8 into 18, it will give me 2.25. So I know that this seems like awkward, and why would we ever use that in real practice? Well, I'm challenging you to see how you can round. So this is clearly, do you know your equivalents, and do you know how to round properly? So what is the rules for rounding? Any number between the number 1 and 10, you round to the tenths. So that's one spot up to the right of the decimal. I look to the number immediately to the right of it. If it's 5 and up, I round up. So my answer will be 2.3 cups. Beautiful. All right. Let me go to this one. Okay, so the question is telling me to convert 0.006 grams to micrograms. So I start with my given. Here's my given, 0.006 grams. I put that over 1. So so this is what I'm saying. I'm putting my given in my numerator position, and I put it over 1 just to remind me that I'm working with fractions. My wanted is micrograms. I put that in a fraction again, micrograms, I need in the numerator position, and the 1 is in the denominator. So it just helps keep me focused. When I find myself drifting off or getting confused, I just try to refocus and start over. So now I have my given and my wanted. So I need to figure out how to get rid of grams and get to micrograms. So I have to think of all the equivalents that I memorized. So 1 gram equals 1,000 milligrams. And 1 milligram equals 1,000 micrograms. So how do I set up my fraction to get rid of my unwanted unit? Unit's not a problem. I set up another fraction, and I have grams here, so I'm going to make sure I have grams here. So I'm going to use my problems and my conversions. So I can write 1 gram is 1,000 milligrams. Perfect. I cross off gram. And now I have to get rid of milligrams. Well, I'm going to use my equivalents. So now I can say 1 milligram is 1,000 micrograms. Gets rid of my milligrams, and I'm left with micrograms, and that is exactly what I need. So now it's just math. So 0.006 times 1,000 times 1,000 will give me an answer of, and I'll put it down below, 6,000 micrograms. Yay! All right. All right, let's knock this out. So my given, 75 milliliters. Put that over 1. My wanted, teaspoons. Put that over 1. I have to think of my equivalents that I memorized. So I remembered 1 teaspoon is 5 milliliters. So I'm going to use that in my problem. No worries. So 1 teaspoon over 5 milliliters. And I do that so I can cross off my unwanted unit diagonally. And it leaves me with a teaspoon. So now I have 75 over 5. And when I do the division, it'll give me 15 teaspoons. All right, beautiful. All right. So this question is asking you, just in case you can't see it, convert 3/4 pint to milliliters. All right, so basically you have to make a decision if you're going to use a fraction or a decimal. So you have to know how to do both, so you know which one to do. So a lot of people go right to the decimal, so I'm going to show you how you could do it with a fraction. So the given is 3/4 pints. You can leave it in the fraction format. It's just that this is your numerator and denominator already there for you. So I can use fraction by saying 3/4 pint, and I need to figure out how many milliliters are in a pint. So I know that 1 pint is 480 milliliters. So I'm going to use that. 1 pint is 480 milliliters. This allows me to cross off pints and leaves me with milliliters because milliliters was my wanted. So no worries. So now it's math. But where people usually make an error is they forget about the 4. So 4 times 1 is 4, and 3 times 480 is 1440. And when I divide 4 into 1440, it does give me 360 milliliters. And that is your answer. So if you wanted to do it in a decimal, you would have to take 3/4 and divide 4 into 3, and that will give me 0.75 pints. Put that over 1. I want it as milliliters. 1 pint is 480 milliliters. Gets rid of my pints, leaves me with milliliters, which is right where I need to be. And now it's just math. So 0.75 times 480 still gives me 360 milliliters. Beautiful. All right, what about that one? I'll give you a minute to try it. All right, let's do it. So we can do it again. You got it, Charisse. All right, we could do it again as a fraction or as, Angelique, good, or as a decimal. So convert 1.5 quarts to milliliters. So as you move through, you're going to be doing this a lot faster now. You're going to be like 1.5 is 1.5 quarts. Beautiful. Put it over 1. And then I need to remember, out of my equivalents, 1 quart is 960 milliliters. So I'm going to use that in my problem because I, in fact, am solving for milliliters. So I put quarts on the bottom. So I'm going to use my equivalent. 1 quart is 960 milliliters. That crosses off my quarts, leave me with milliliters. And now it's just math. So it's 1.5 times 960, and that will give me 1,440. Never forget my unit of measure, milliliters. Now, if you wanted to use a fraction, you would take 1.5. You would do 2 times 1, which is 2, plus the numerator is 3, and the answer would be 3 over 2 quarts. And then it's the same thing. 1 quart is 960. I just have to remember to move my denominator over. So this would be 2, and 3 times 960 is 2880. And then it still gives me 1440 milliliters. Beautiful. All right. All right. Convert this one, and then we're going to move on. All right, let's just do it real quick for the video. My given, 178 pounds. I put that over 1. My wanted is kilograms. Put that over 1 because I need kilograms in my numerator. So I have to remember that 1 kilogram is equal to 2.2 pounds. Because I have to get rid of pounds and get to kilograms. So I'm going to use this equivalent in my equation. No worries. 1 kilogram, and I put 2.2 pounds on the bottom. Why? So I can cross off the like amounts in the numerator and the denominator. And now it's just math because I'm left with my kilograms right where I need it in the numerator. So 2.2 times 1 is 2.2. And then I do 178 times 1 is 178. When I divide 2.2 into 178, it'll give me 80.90. Any number greater than 10, I round to the whole number. So I look to the number to the right because this is the whole numbers, the numbers before the decimal. I look to the number to the right. It's greater than 5, so I round this up. So my answer on my answer line is 81 kilograms. Beautiful. All right, here you go. Solve for this. So again, read your questions. Good. Good, JL. You got it. So the order is to prepare a half-strength tube feeding. How many milliliters of water will the nurse add to the 4-ounce can? So they want you to tell them how many milliliters of water. My wanted is milliliters of water will be added to the 4-ounce can. So what's my given? My given is the 4-ounce can because that's what's available. Put that over 1. So how do I change ounce to milliliters? I memorize my equivalents. So I know that 1 ounce is 30 milliliters. Crosses off my ounces. 4 times 30 is 120 milliliters. But how do I get 120 milliliters? It's a 4-ounce can. So the 4-ounce can is 120 milliliters. But I have to make it half strength. So I know you all are familiar with the rapid cheater way to do it, but I'm going to show you how it would really happen. So you walked into the pantry and they had a 4-ounce can. We're going to pretend this is a 4-ounce can, by the way. All right. So it's a 4-ounce can. So I know to make half strength, I have to add equal parts water. So I need to add 4 ounces of water. But how am I going to fit the ounces in the water? Well, when you're working clinically, you'll have a bag that you can mix it in. So you would pour the 4 ounces of formula in the bag, and then you'd pour 4 ounces of water in the bag, and that would make a half strength diluted feeding. So for you, you just need to figure out how many milliliters is 4 ounces, because remember, feedings are counted in intake and output. So we only solve intake and output with milliliters. So the question says, how many milliliters of water will the nurse add to the can? So to make this half strength, she has to add 4 ounces. But what if I asked you, what's the total volume the patient will receive? So the total volume is 240 milliliters, because we had 4 ounces of feeding and 4 ounces of water. So we add them together, that's 8 ounces. So there's a lot of ways you can do these. You can do it individually, or you can tally it up if they're asking total volume. So 8 ounces, if you were to do dimensional analysis way, would bring you to 240 milliliters total volume. Good. All right, I'll have you do another. So you guys have got the knack. So the way we usually do it, the way we usually break it down, and you can even show me this work on the exam like this. How many milliliters of water will the nurse add to a 5-ounce can? So you have a 5-ounce can, and you have to make it half strength, which is 50%. So you need to add 5 ounces of H2O. So you can do this and this. And you're going to answer how many milliliters of water will the nurse add. So you just have to solve 5 ounces over 1 times 1 ounce is 30 milliliters. And 5 times 30 ounces is 150 milliliters. I think my pen's dying, is 150 milliliters. But if I came back and I said, what is the total volume the patient will receive? Then you would have to say 5 ounces plus 5 ounces is 10 ounces. And then you do the same process. 1 ounce is 30 milliliters. Cross off my ounces, I'm left with milliliters. 10 times 30 is 300 milliliters. So basically what I'm telling you when it comes to enteral feedings, they're only going to ask you 2 different ways. Okay, they're either going to ask you how many milliliters of water will you add to dilute it to half strength or 50% strength, or what was the total volume the patient received of the feeding. And that's when you would have the formula and the water. All right, cool. All right, solve for this. So Julianne, check your math. All right, so many of you are tempted to do this problem without doing the process and the steps. That really will help you. You get a little caught up wanting to solve it using your fingers and toes, and I totally get it. Like you're like, okay, 3 to 10 and 5 is and another 5 is 4. It's very difficult to do that, especially when we're dealing with a lot of numbers and volumes and things like that. So trust me about this process. All right. So when we talk about typical math setup, we start with the larger number. So the larger number is 1900. And then we want to subtract the smaller number, 1315. But remember, we're talking about nurse math and nurse time. So essentially, we have to separate hours and minutes to think about it. So this side represents hours and this side represents minutes, because we are talking about time. So when you're looking at this question, you can't take 15 minutes from 0 minutes. You can't, all right, because we're talking about time. So this is why I encourage you to do this long, drawn out process, because it ultimately will help you understand it too. So how do I get these numbers to make it so that I can take 15 minutes from it? Well, this is where we borrow or steal time. So I'm going to take 1 hour from the 19. So if I take 1 hour from 19, that makes it 18. So 1 hour I can give to my minutes, but in the form of minutes. So 1 hour is 60 minutes. So 60 times 00 is 60. So it changes this to 1860. And now I just move my 1315 over. I still remember this represents hours and this represents minutes. And guess what? I can take 15 minutes from 60 minutes. And when I do, it leaves me with 45 minutes. So then I subtract 13 hours from 1,800 hours, and that will give me 5 hours. So this asked you what the total time it took to infuse this feeding into the patient. So it took 5 hours and 45 minutes. That's how long that feeding was running into that patient. So when you write things like, if you wrote 545 or 045, this 0545, I'm sorry, this is telling me time. What time? This is 5 a.m., 5 a.m., 5:45 a.m. This could be, it could be something, I don't know, 5:45 p.m. It could be anything. It should be, well, we don't write p.m., we use military time. So this asks you the total time it took to infuse, not a time. This would be wrong. All right. So do this. Let's do it. So they started feeding at 15:30. It ended at 20:05. What's the total time the feeding infused? So I'm going to start with the larger number. I'm going to put it over the smaller number. I'm going to subtract. I always do this, even though I know it because I do it a million times. But it keeps me focused. And I realize I can't take 30 minutes from 5 minutes. So I'm going to borrow an hour. That will make it 19. And I'm going to give 60 minutes. And that will give me 65. I just move this time over. And now I'm ready to solve. So 30 from 65 leaves me with 35 minutes. And 15 from 19 is 4 hours. So my answer on my answer line would be 4 hours and 35 minutes. That is the total time it took this feeding to run. Beautiful. Let's do another one. Keep it going. So same principles. I'm going to start with the larger number. I'm going to subtract the smaller number. I still draw my line to identify hour and minutes. And then I realize I can't take 20 minutes from 10 minutes. So I'm going to borrow time. I'm going to take an hour and make that 13. I'm going to give it to the minutes, which would make this 70. And then I'm just going to bring over. Now you notice I'm still keeping the 0, 6, 20 because we're talking about time. All right, hour, minute. And now I just subtract. So 20 from 70 is 50 minutes. And 6 from 13 is 7. So this it took 7 hours and 50 minutes for this enteral feeding to infuse into the patient.
All right, question.
Yeah.
So I'll be
Here's a question for you to solve. All right. So let's talk about this. This is an example of how you reconstitute. And basically, when we're talking about reconstitution, it just means you're preparing the concentration. In the past, nope, Curly, we're going to do it together. Not to worry. In the other questions, you were given concentration examples, but this one you're merely making the concentration. So basically what this looks like, and if you watched module 3, this is where you find it. So it's saying add 8 milliliters of normal saline to 2.1 million units of penicillin powder. So basically they're saying the pharmacy is going to send up this vial of penicillin powder. All right. And on the unit, you're going to mix it before giving it to your patient. So how do you mix it? Well, you would read one of the drug guides or maybe directions of the pharmacist, or maybe it would be available to you in the medication administration record. But either way, it's the question is telling you you're going to add 8 milliliters of normal saline to the vial. Okay, so you're going to withdraw 8 milliliters using a syringe. All right, and you're going to take out 8 milliliters and you're going to then inject it into the vial. So of penicillin. So what does that mean? Well, that simply means that there's 2.1 million units of penicillin in 8 milliliters. That's all it is. You're creating the concentration. And when you create the concentration, you can use it in your problem. So using dimensional analysis, how do we set up a problem? What's my given? Well, the given is the doctor's order. In this question, it says prepare. It may say administer. It may say the doctor ordered. But this one says prepare, meaning the nurse, you need to prepare 1 million units for injection. All right, 1 million. Believe it or not, most people have a problem writing out millions. We don't know why, but we're going to go over it. So you write out 1 million units and you put it over 1. What am I solving for? What am I going to give the patient? I can only give milliliters. That's the only way it's available. So I'm solving for milliliters. How do I get rid of the word units? I'm going to use the concentration I just created. So I said that 8 milliliters gives me 2.1 million units. This lets me cross off units, and now I'm left with milliliters, which is right where I need it to be, and now it's just math. So if you are comfortable with crossing off zeros, here's the time to do it. Just make sure you cross off the appropriate amount, or you can just use your calculator and do 8 million over 2,100,000. But if you want to try the zeros, go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now it's just 10 times 8 is 80. 21 times 1 is 21. And when I divide, excuse me, 21 into 80, it will give me 3.8 milliliters. So I'm going to draw up 3.8 milliliters and give it to the patient. And
I
that's
see what I did wrong.
Yeah, what you do? You reversed it?
I reversed it. I
Yeah.
had 21 million on top
That's
instead of putting it
exactly,
on the bottom.
and that's why we try to, this is one of the things that the most common errors that nurses can make. And you see how your answer, how much more volume that patient would have received. So it could kill a patient, these med errors. So that's why we take these calculations so seriously, because it's so important. So I'm going to let you do this one. Now, in this example, it gives you the concentration. So remember, so think about reconstitution is you're making the concentration, but it's all still there. This just means 8 milliliters is 2.1 million units. But in this question, it gave you the concentration. So I'm going to give you a minute to solve this. Okay, so where is my given? The doctor ordered, excuse me 1 second. So we're looking for the given, and that is the doctor's order. And this question says the doctor ordered 0.5 milligrams. So I'm starting with 0.5 milligrams. I'm putting that over 1. The medication is available as a concentration of 675 micrograms per milliliter. How many milliliters will the nurse give the patient? So my wanted is, this question is telling me how many milliliters am I going to give to my patient? So I have my given and my wanted. Please feel free to cross off while you use things too, whatever helps keep you focused. So now I have to get rid of milligrams and get to milliliters. I do have a concentration, but the problem is the concentration is in micrograms per milliliter. So I need a conversion from milligrams to micrograms. And hopefully I memorize that 1 milligram is equal to 1,000 micrograms. And I'm going to use that to get rid of my milligrams. So 1 milligram is 1,000 micrograms. I cross off my milligrams. Now I have micrograms to get rid of. Now I can use what's in my problem. I have 675 micrograms in 1 milliliter. That gets rid of micrograms. And look at that. I have milliliters in my numerator. So now it's just math. So 1 times 1 times 675 is 675. And 0.5 times 1,000, excuse me, is 500. Now I divide 675 into 500, and my answer, my calculator will give me 0.74074. Any number less than 1, I round to the hundredths. That's 2 spaces to the right of the decimal. I look immediately to the right. It is not 5 and greater, so my answer is 0.74 milliliters. And I will draw that up and inject it into my patient.
I
Beautiful.
have a question.
Sure.
I did it the same way, but I did it reverse. Like I put down 0.5 mgs over 1 times 1 ml over 675, and then I put 1,000 micrograms over 1 milligram. Does that matter?
No, as long as you get the right answer and it doesn't confuse you. I write it out in fractions the way my brain works. So yeah, if you can manage your units of measure, doing it the opposite way, that's fine.
Okay.
Absolutely. Yeah.
And I think I didn't write the 4. I just wrote the 0.7 ml. Would I have gotten it wrong?
Yep, that's a rounding error. So you would lose a point.
Okay.
Yep, absolutely. All right. Let's do another. All right, so let's first find the given. So the given is the doctor's order. So in this question, where is the given? Well, the given is the doctor's order. This says prepare 625,000 units for injection. That is my given. I'm starting with my given. 625,000 units. I put it over 1. And then it says I have to mix sterile water 5 milliliters to a vial containing 1.3 million units. That means what? 1.3 million units in 5 milliliters. Okay. Well, how do I get rid of units? Because I'm solving for what? Milliliters, because that's what I have to give. Milliliters. So I can get rid of units by using my concentration that I just made. So it'll be 5 milliliters over 1.3 million units. That gets rid of my units. Beautiful. Now let's get rid of some zeros. 1, 2, 3, 1, 2, 3. So 1 times 1,300 is 1,300. And 625 times 5, I don't know. I have to do the math. I'm sorry, because I did it the long way originally. So 625 times 5 is 3,125. And when I divide that by 1,300, it will give me 2.403846. It'll keep on going. But the bottom line is this number is between 1 and 10. So I round to the 10th. That is 1 decimal to the right. And 0 is not 5 and up. So my answer is I will give and administer 2.4 milliliters to my patient. Beautiful. Let's keep it going. Okay, so this question confuses most. So the medication, the doctor, well, let's start with the given. The given is the order. Administer 13 milligrams. That's the order, 13 milligrams to the patient. Put it over 1. What is my wanted? Well, this one tells you how many milliliters does the nurse give? You're the nurse, so you're solving for the milliliters. What are you going to give that patient? And it's stocked in a bottle that has 12.5 milliliters in it, and the concentration is 3 milligrams per milliliter. So everybody wants to use the bottle, but what does that mean? When you go to the store and you pick up a bottle, this bottle has 12.5 milliliters in it. Well, you're not going to give the bottle. It shouldn't even come into the equation. You're going to look at the concentration of the bottle. So you know if my baby needs 10 milligrams of Tylenol and the bottle said 10 milligrams per 1 ml, you're going to give 1 ml. Well, this is exactly what the question's asking you. It's saying it's stocked in this bottle and you go to the med room and that's what's in there, but the concentration is 3 milligrams per milliliter. That's what you use. I know how I get rid of milligrams and get to milliliters. I'm going to use the concentration. I don't need the total volume in the bottle. It's not helping me solve my equation. It's just telling you that's what it is. So if you got 54 and numbers in the 10s and 20s, it's incorrect because you used the total volume in the bottle. So we need to use the concentration. Every milliliter has 3 milligrams. So I put that in my equation and I cross off my milligrams and I'm left with milliliters. And now it's just math. So it's 13 over 3. and that will give me 4.333, which will be 4.3333. 1 to 10, round of the tenths. 3 is not 10 and up, or 5 and up, so the answer is 4.3 milliliters. I'm going to switch to another sheet real quick. So here's another equation. Please solve. All right. So I always start the same process. What is my given? My given is the doctor's order. And the doctor says administer 1100 micrograms to the patient. No problem. 1100 micrograms. I put that over 1. My wanted is what? How many milliliters will the nurse, you, administer? So I'm solving. My wanted is milliliters. So I've used this and I know what I'm solving for. Okay, cool. So I have to get rid of micrograms. The only other thing in my question that is available is in milligrams. So I need a conversion. I need an equivalent. So 1 milligram is equal to 1,000 micrograms. So I can use that on my problem. Beautiful. So 1 milligram is 1,000 micrograms. It gets rid of my micrograms. Beautiful. But now I have to get rid of milligrams. And here is where I can use what's in my question, because it has everything I need. It has milligrams and milliliters. Beautiful. So let's use it. So 0.9 milligrams, I put it in the denominator position, put 3 milliliters in the numerator. This allows me to cross off milligrams, leaves me with milliliters, and now it's just math. Beautiful. So 1,000 times 0.9 is 900, and 1,100 times 1 times 3 is 3,300. And then I divide 900 into 3,300, you will get 3.6666. 1 to 10, I round to the tenths. That's 1 decimal to the right. I look at the number right after it. If it's 5 and up, I round this up. So the answer is 3.7 milliliters. Beautiful. Let's do another. Try this one. All right, let's do it. Find my given, find my doctor's order, administer, yes, 922 micrograms to the patient. So this might be a little NICU patient, a little neonate. You never know. So the preparation available is a concentration of 1 milligram per 1 milliliter. How many milliliters does the nurse administer? So I am solving for milliliters because it's asking me how many milliliters will I give. All right, I've used those two. So 920, I have to get rid of micrograms and get to milliliters. But the only other thing in my problem is milligrams per milliliter. So I need a conversion. So again, 1 milligram is 1,000 micrograms. Beautiful, I'm going to use it. 1 milligram is 1,000 micrograms. That allows me to cross off my micrograms, and that leaves me milligrams, but I need milliliters. So I'm going to use my problem. My concentration is 1 milliliter has 1 milligram in it. That lets me cross off milligrams, and now I'm left with just what I need. So 922 times 1 times 1 is 922. 1,000 times 1 times 1 is 1,000. And when I divide 1,000 into 922, it gives me 0.922. Less than 1, I round to the hundredths. Right? The hundredths is 2 spots, right? To the right of my decimal. 1, 2 spots. So then I look to see if I need to round up or stay the same, and it's not 5 and up, so my answer is 0.92 milliliters. Beautiful. So if you put 0.9 milliliters, you will lose 1 point. If you put 0.9 milliliters, you technically should get the whole answer wrong, because what did you forget? The 0, and you forgot to round to the hundredths. But I could be lenient depending on the situation. I would have to see the setup. Okay. So don't forget, make sure. And if you round to 1, you're going to lose a point, because I would know from your setup and from my answer key that you rounded incorrectly.
What if we forgot the part where it's 1 ml over 1 mg and solved it before that?
If you mean you left it off in your equation?
Yeah, but if you got the answer right.
Yeah, if you are doing things differently in your calculation, that's fine. You're going to have paper with these example, with these exam questions on it, and it's going to have a line on it that says answer. with one line. You just got to put the correct answer with the correct unit of measure. You know what I mean? But I use I need to see your work so I know what you're doing, how you're solving, because if there are issues, then maybe I can help you solve and figure it out. The only thing we didn't get, oh, going back to my question, added the extra 0. Yeah, it's wrong because you don't have trailing zeros. You can't have a trailing 0 after a 1, like if it was, the answer was 1.0, it's wrong because that could be mistaken for 10. But if your answer is 0.92 and you added a trailing 0, no, it's wrong. You don't have trailing zeros. Let's call it, yeah. Just don't put the trailing 0. It's minus 1 point, yeah. Rounding errors is 1 point loss. So on your exam, there are 10 questions. You have 30 minutes to complete them. The only thing we didn't review today was intake and output, but intake and output is a series of conversions. That's what that is. Let me see if I have an example of what that would look like. Maybe not. Oh, so this is what I mean by it's just a series of conversion. If you were told to calculate the intake and output, remember what? Intake is one number and output is another number. You have to know what counts as intake and what counts as output. Well, this question is pretty easy. There's no scenario or story, but I can say if the patient had 4.5 cups of water, that's intake. 1.25 pints chocolate milk, that's intake. 8 ounces of coffee, that's intake. If it said 2 pancakes and 2 eggs, that may be food, but it's not liquid. Intake and output is always in milliliters and it's always 2 numbers. And then output, you will identify what is counted as output. They voided, you know that voiding means urinating. They voided 800 milliliters and 750 milliliters during your shift, but then they also vomited 1,300 milliliters. So it's just a matter of calculating these questions. It has to be in milliliters. So you would have to convert 4.5 cups to milliliters, and you would do it. That's what I mean by a series of conversions. So you would cross off your cups, you'd end up with milliliters, and 4.5 times 240, I have to look, I don't remember, is 1080 milliliters. Okay, so I use that one. 1.25 pints is 1.25 pints, and I put 1 pint is 480 milliliters. So that's what I mean by it's a series of conversions. So you have to know the conversions. So a quarter pint times 1.25 times 480 will give you 600 milliliters. So you do all this, you convert everything to milliliters, and then you tally up the number. So let's do this one. 8 times 30 is 240. So when I tally up the intake, it's 1,080 plus 600 plus 240. And that will give intake, you would write intake, 1,920 milliliters. And then you tally up the output, 800 milliliters times 750 milliliters times 1,300 vomiting or emesis. And that will give you 1,663 milliliters output. So that's how you do intake and output. So here's a strategic plan that you might want to consider. If you know that intake and output takes you longer than any other problems, then certainly save it for last. It's better to, if you run out of time, it's better to lose just one question, 5 points, than lose 15 points, let's say, or 10 points because you couldn't finish 2 questions because this one took you so long. So you could be a little strategic in that way when you do your calculation exams. Even moving forward, if you know a certain IV type of question takes you forever, then save it for last. Just remember to go back. I have a request to do an insulin question. Sure. Hold on 1 second. Let me pause the video. All right. So when you receive an insulin question, or when you receive orders when you're practicing and going to clinicals, this is how insulin orders are generally written if they need what's called coverage, additional coverage to bring their sugar down. So they'll add additional orders. So when we look at this, the order, the first order says, this is number 1, the patient requires Humulin N 4 units mixed with Humulin R 4 units before meals. So they may get it at 7 a.m., 12 noon, and then 4 p.m., let's say, I don't know. So maybe this would be 11 a.m. So they would definitely get an AC before their meals. So we know we're getting this ordered insulin before their meals. Okay, awesome. But then they say there's also coverage order. So it's based on the patient's blood sugar. So as the nurse, before you go in to give any of the ordered insulin in the first order, you have to prick their finger and get a dab of blood. So in this example, they say at 12 noon, which is before lunch, they go and do a finger stick, and the finger stick is 149 units. And the doctor's order says you cover the patient with regular insulin based on the finger stick. Well, the finger stick was 149. So where does 149 fall in this coverage order? So when you look at the coverage order, 149 falls here. And that says no insulin. But the question says, what is the total amount of insulin the patient will receive before lunch? Well, you have to give him the 4 units of N and the 4 units of R. But his blood sugar didn't require any additional insulin. So his total amount is 8 units. And that's how you do the insulin calculations. Right. You got it, Sherry. It's good. Yes. So that's the total amount of units. So let me see if I have another one. So here's another one you could do. So these are how the insulin orders, Carly, you put a 0 before that, might just be a typo, no worries. But you can't do that on the test. Make your errors here. Yeah. All right. So what is it saying? It's saying, what is the total amount of insulin the patient's going to receive before breakfast? All right, cool. So I have to give them, the first order is 12 units of N mixed with 8 units of R before meals, because I know AC means before meals. All right, cool. But I have coverage orders. And it says, based on a finger stick before the meal, what will you give additional coverage of R? So the blood sugar was 348. 348 falls between 301 and 350. So that means the patient is going to get 12 units, 8 units, and then another 10 units. And that's a whopping 30 units of insulin. That is your answer, 30 units. Pretty cut and dry, right? Definitely go to your D2L Brightspace page. The YouTube site is there. And then also that's where you find the link. All right. So please, thank you for joining with me and practice.
Some questions.
Sure.